going to discuss about sim software. So here I am using 13.0 version. So first let us go to the uh, uh, design, and you go to place components. In that first let me select resistor. Okay, so I require nearly 3 to 4 resistor. So I'm going to select the resistor. Okay, so if you press OK, you will get continuous. Okay. Next, so before going to this one, you must know what are the components which are required. So you require a DC power, right? So that is of 20 volt. Okay, then I require capacitor. Okay, so I'm going to select capacitor rated. So I selected the capacitor. I require nearly 3 capacitors. So next, I'm going to select the voltage source. That is AC voltage. Next, I need to select the transistor, which is Q2EN22. So instead of going to all groups, you better go to all menu bar and they select the transistor. So in that you can see there is 2N42s, right? So instead of writing Q2, we select 2N4+. Okay. So it will be here. Okay. So this DJT NPN transistor. So that is enough. We can see there is Q1, 2N, 4 bits. Next I'm going to select the Bode plot. Now I'm going to give the connections from the one end of the capacitor start to the AC voltage source. I'm going to change the orientation of the resistor. So if you click rotate 90 degree clockwise, it will change. Okay. So next I'm doing the alignment. So I have to right click. Okay. I also repair on inductors. So it will connect it later. So according to the circuit diagram, I'm just connecting the values. Yeah. So we are connecting the RE and C capacitors. So you have to connect it to the red line. Okay. So I can do it like this, or I can select all the components and they can change this. So afterwards you can change this resistor. Okay. Next, I don't require this resistor actually. Okay, there you have inductors. So the other end of the negative voltage is supplied to the ground. So I connected the ground so far. Next, and just selecting. So since it is a tuned network, you have L and C at the collector terminal. So the detailed video regarding the tuned collector circuit is I will give it in on the description box, so you can select it. So you can go for all groups and then you can select the ground and the inductor. So you can select the ground from here or from the menu bar itself. You have a ground. So I require nearly 3 downs. Okay. So I'm just clicking OK on that, making the connections. Now I'm connecting the other end of the AC source to the ground. So I'm rotating the inductance. Okay, and just connecting that tune the network. So the parallel of L and C is nothing but a tuned network. Since it is connected to the next, I'm going to get the connections to the positive power supply, and then this is the input and this is the output terminal. So output terminal is connected to the collector of the transistor, and the input terminal is connected to the input of the AC voltage source. Okay. Now next I'm going to change the value of the AC voltage source. So whatever the value I'm giving, you note it down. So I'm going to save this project as tuned collector oscillator. So I need to connect the ground there. Okay. So here the ground is connected only to the R4 terminal. So just deleting this one and giving connection like this. So you can see there is a red dot has come in. So that represent the node. Okay. So I need to change all the values of the capacitance. Okay. So I'm giving the capacitance value as 100 nanofarad. Inductance resistance as 80K, and this is quantity K resistor. And then this inductor capacitance as 1 nanofarad. Then inductance value. So you know the frequency, right? So F is equal to 1 divided by 2 pi root LC. So here I am giving it as 35.65 microfarad. What is the value of L? Here it is L1, and the capacitance value I'm going to get as 1 picofarad. 1 picofarad. Okay, and there is just changing the supply DC supply voltage is 20 volt. So here I'm changing the voltage VPK value as 10 volt and frequency as 10 kilohertz. And this capacitance I'm changing it as 10.5 picofarad. 51 picofarad. Okay. So once again, I'm saving this project and giving it the run. So we get the output like this. So you can see there is some peak. So if I move that vertical line or this right arrow, you can see that the vertical line is moving, or with the help of mouse you can just drag this one and you can see I'm getting 1 megahertz frequency works with get the peak value. So this is due to f is equal to 1 divided by 2 pi root of L value is 35.65 micro and C value is 710.51 picofarad. Okay. So once if you adjust this value, you can see that it is changing and you will get the output like 1.00077 megahertz. Okay. So if we change this I, it is moving upward, right? So you can adjust this logarithmic value now to obtain uh, the desired output, right? So that's all about this video. So I hope this video is useful for you. Thank you very much for your passion with this time.